So back to properties of the nth root of a. If n is even, so if you have an even index, then if a is greater than or equal to 0, the nth root of a is a real number. And that's okay. But if n is even and a is less than 0, meaning it's negative, then the nth root of a is not real. If n is odd, a can be, positive or negative. So the nth root of a is real. So what does that mean for us in terms of radical functions? For the domain of a radical function, if n, if n, the index, so if it's even, then the radicand has to be positive, greater than or equal to, can be equal to 0. So it has to be greater than or equal to 0. If the index is odd, then the radicand can be any real number. Okay, so what they want us to do is they want us to find the domain of a radical function. And it's this part up here that's going to be important to us. So an example for it says find the domain of the function f of x equals the square root of 6x minus 5. Write the domain in interval notation. Okay, so this has an even index because it's a square root. So it's a square root. So the index is 2. Okay, so what that means is the radicand, now the radicand's the stuff underneath the radical, the 6x minus 5, that has to be greater than or equal to 0. Now that's an inequality, and so we want to solve the inequality. Add 5 to both sides, divide both sides by 6. Okay, and you didn't have to switch the radical you didn't have to switch the inequality because you divided by a positive 6, so that's okay. So we're thinking about all the numbers that are greater than or equal to 5 over 6. On a number line, that would be here's 0, here's 1, here's 5 over 6. So all the numbers that are greater than or equal to 5 over 6. They don't ask you to graph it. I'm just showing it to you. So here comes the interval notation, square bracket, because we're going to include the 5 over 6. It can equal 0, to infinity, parenthesis. This would be the domain. It's the numbers that you can use in the function. Okay? Oh, that's it.